So when we're talking about Hookes Law, we can use this as a way to make some estimations. And rather than always having to collect data, we can say, okay, if we have this light spring that we started with, the weak spring, the number one spring that has a spring constant of 3.1, okay, how much does it need to stretch in order to give us a specific force? So if we wanted to know how much this spring needs to stretch to provide 15 newtons of force. How much does each spring need to stretch to provide 15 newtons of force? Now, of course, we are making some assumptions here, specifically that these springs can actually stretch that long. This may not actually be possible, and that's okay. There will be a limit at some point. These springs may not stop acting in this way, but we're going to assume that we're going to be able to do that. So in order to do this, let's start with the light spring here. We have 15 newtons of force. We know that the spring constant is 3.1 newtons per meter, and we want to find our delta x, how much stretch we have to do. So we will divide each side by 3.1 newtons per meter. Newtons per meter cancels out, newtons cancels out, and so we will have 15 divided by 3.1. Let me clear this out. And we get 4.8 meters. So we'd have to stretch the weak spring 4.8 meters in order to get that much force. Now, if we look at the strong spring, we can set this same equation up as well. Again, 15 newtons. This spring has a constant of 12.5 newtons per meter. And again, if we solve for this, dividing each side by 12.5 newtons per meter, 15 divided by 12.5 gives us 1.2 meters. Okay, and those numbers should make sense. We know that if we have a strong spring, it's going to have to stretch a lot less in order to provide the same amount of force as a weaker spring. In this case, the spring constant is about 4 times larger. 12.5 is about 4 times larger as 3.1. So we'd have to stretch the strong spring about 1/4 the distance we stretched the light spring. And so that should make sense. And so we can use this Hookes law in order to estimate how much force is needed to stretch a spring. Now, the big question though is, how is all this related to energy? And so that's what we're